Waste incineration, the chronic poisoning of the people. Part 12. Cryogenic plastic recycling or Kryo Recycling. With the deep temperatures of a cryogenic recycling process down to 160 degrees Celsius, the mainly thermoplastic synthetic materials, more than 90% of the plastics used, and illomaster rubber products are made brittle. They then easily can be ground to fine powder. Pulverizing makes fine sorting possible. Especially the fine pulverizing permits separating the plastic grains of the intact original mass, the inner part of the plastic products, from the grains of the altered surface layer. The grains of the intact original mass make real recyclates. The altered grains of the surface layer make material for downcycling. The cryogenic recycling process already has been extensively prepared. It was not only tested on a laboratory scale, but also examined, found to be good, and shaped by specialists for refrigeration technology and mechanical process and sorting technology, and by industrial engineers. Mannesmann Anlagenbau AG, Plan Engineering, had been collaborating on for it more than 2 years until the cooperation was abruptly stopped due to the takeover of the corporation by Vodafone. The 3 innovative process stages considerably reduce the previous operating costs for deep refrigeration technology, crushing technology and sorting, so that the marketability of the plastic recyclates as regards both price and quality has been economically reviewed and can be predicted as certain. The new low-temperature refrigeration technology used the 3 natural gas refrigerant program. Was da? Das ist jetzt hier aber. Wo kommt das denn her? The low-temperature refrigeration technology used the 3 natural gas refrigerants, propan, ethan, and methan, not in separate cycles as in conventional cascade techniques, but as a mixture in a one-cycle system as in an eco-refrigerator Greenfreeze. The main compressor only has to develop a pressure of 15 bars to liquefy the propan. The cascade likefall in temperature occurs without additional power consumption by fractional vaporizing of the refrigerant in a short circuit. The methan vaporizing at minus 161 degrees Celsius cools the grinding tunnel into which the scrap plastics, used tires or electronic parts crushed into palm-sized pieces beforehand, all brought via a sluice to utilize the vaporization enthalpy of the 3 gases in the best possible way. They are returned to each reach the main compressor via a Roots-type pre-compressor with a technically favorable, relatively high suction gas temperature. To enable a compact construction of the grinding tunnel, the indirect cascade cooling of the grist is complemented by direct cooling according to the heat pipe principle in the tunnel. The latter increases the heat transition and provides for this direct continuous frictional heat removal from the grist. Compared to the old cryogenic recycling with liquid nitrogen, the operation costs go down to approximately a tenth. The cost advantage considerably extends the range of economic applications. The advantage to the hydrocarbon mixtures in the cooling cycle results from the tendency of the gases to establish van der Waals interactions in mixtures. These weak bounding forces contribute to the formation of molecular clusters during condensation, thus increase the condensation enthalpy and in succession also the vaporization enthalpy. Overcoming the mixture included van der Waals forces increases the volumetric refrigeration capacity and the energetic refrigeration gain. These physical-chemical principles of innovative refrigeration technology were presented and successfully defined by Professor Harry Rosin with the help of IR spectroscopic analysis and 2 lectures at the University of Göttingen and before the VDI and VDI at Göttingen. The initiative refrigeration technology also passed the tests conducted by the industrial refrigeration engineers. In the mid-1990s, it was discussed in detail with refrigeration engineers of Messer Griesheim, Krefeld, and considered to be good. They would have liked to take part in an industrial realization if the mother company at the time, Höchst, had allowed them to change from liquid nitrogen to the hydrocarbon mixtures. The cost advantages compared to conventional refrigeration technology in the low temperature field using liquid nitrogen were confirmed inter alia in feasibility studies. The new grinding technology in the refrigeration tunnel. The material which is not shock frozen but is gradually embrittled is caught between the central working rules with only partially projected into the compact tunnel. The grinding and pressure is reinforced by external supporting rollers. The rolling must similar to the Sensimir mill proven in metallurgy and the cement industry. The roll guide, however, reacts flexibility to disturbing lumps or in case the grist piles up in front of the roll gap. The desired grain size can be adjusted variably. It required up to the finest of powder. Tire producers demand a grain size of less than 80 micrometers for rubber recyclates. It could be proven in electron-optical analysis that with the innovative grinding technology, grinding down to a size of 20 micrometers is possible, if required, with the particle surface remaining rough and active, not being smoothed by friction heat. Contraries like attached dirt or heavy substances like metal and materials are removed parallel to the grinding process by air separation or sieves. The medium for direct cooling, according to the heat pipe principle outlined in Figure 11, protects against dust explosions during the fine grinding of used tires. It also prevents the secondary oxidation of the polymer chain at the intercrystalline breaking points. The flotation of the mixed powder at the end of the grinding process was granted by special pin miles. In principle, the mechanical process engineering follows the good example set by Messer Griesheim with its offers of recycling as using liquid nitrogen. Online classifying with high flow rate and sharp separation boundaries up to the micrometer level. That's from the Messer Griesheim brochure. Messer is a company making liquid gases. The advantages of the innovative cryogenic recycling. It does without relatively expensive liquid nitrogen and offers the cost advantage of a natural gas hydrocarbon mixture, which can be used to optimum efficiency in the closed refrigerant loop. The price advantage were professionally proved. For plastic processors and producers of tires and other technical rubber products, conveyor belts, sealings, materials and so forth, the success and the market can be regarded as assured. at the latest since the price of crude oil rose more than $100 per barrel. Third, the new separation technology. The different separation and sorting process connected in series via conveyor belts already start in the refrigeration tunnel. In the refrigeration tunnel, for example, advantage is taken of the fact that the well-known electrostatic separation according to the ester process is not impaired by conductive water. Further methods, partly compressed to the highly developed state of the art, the method-resimed cryo-class process. Additional innovative processes improve the fine sorting of the mixed powder, which contains numerous types of material. A highly unmixed result, also sorted according to color and very gentle treatment of the material, preserving the active surface of the fine grain are possible. The fine graining makes it possible to separate the grains from the surface of the plastic parts, which often is changed and worn out from the grains which still consist of their completely intact base mass. Even after many years of use, the waste plastics only are used up right at the surface. As a rule, 60 to 80% intact base mass remain, which can be recompounded using the well-developed methods of state-of-the-art chemical technology. Suitable additives mixtures for recompounding can be obtained from Cyberspezialitätenchemie if necessary. It has been demonstrated that the recompounding of recyclates can produce plastics of primary quality or with even better mechanical properties, except that the products from recyclates are much cheaper for plastic processors because cryogenic recycling uses about 40 times less energy than the synthesis of new molding materials. A group of scientists and engineers who took forecasts of destructive climate change seriously at an early stage extensively prepared the cryogenic recycling process decentrally for industrial use. In qualitative respects, the results are encouraging. It has been proved that scrap plastic can be further processed into new high-quality products. Their incineration, often only after a single use, is not necessary. Even the grains from the surface layers, which often are changed by imprints or wear and tear, can be put to good use, for example, as material to protection cars underbodies against corrosion. This is more a downcycling than a recycling, but still a useful further application of the material. The many disadvantages of the waste incineration plants, high thermal emission, high rate of conversion into toxins in slags, dust or flue gas, can be avoided for at the low temperature the use-friendly original material composition of the products is not changed at all. And now new toxins emerge. It is now time to embody the 12-year development phase in the industrial pilot plant and optimize it. The pilot plant, as well as future operating facilities, should be designed for medium-sized firms. According to previous calculation, the proceeds of the recyclates are so high that facilities with a capacity of 1 ton per hour or more an 8-hour working day can operate economically. The plant size should not exceed a capacity of 5 tons per hour so that the transport distances remain short. For the plastic producers, because on the one hand they can contribute their processing knowledge to the recyclates business quality assurance, and on the other hand will likely be able to sell even better, more expensive high-tech products with offer recycling on the world market. The total amount of waste that could be treated by cryogenic recycling amounts about 20 million tons per year. That corresponds to the decrease in coal output from 47 million tons in 1997 to 26 million tons today. The value created from a high-quality waste would be plainly higher than from coal mining. The number of jobs would be financed themselves through the conversion of material would be enormous.